Welcome to Unit 1. We are talking about key features of quadratic functions, Part 1 in this lesson. First of all, what is a quadratic function? Simply put, a quadratic function, it's an equation, a table, or a graph in which the x value, or the unknown variable, is squared, meaning it has an exponent of 2. Here are some examples of quadratic functions in their different formats. As an equation, the parent function, or the most basic form of this function, is y equals x squared. Sometimes, instead of seeing y equals, you might see f of x. Well, remember how we called this a function? That's kind of where this f of x comes in. So y is often called the output. And x is often called the input. So if y is what you end up with when you put in an x value, then y is really just a function or something that happened to the x value. Now, you don't always have to have just y equals x squared or f of x equals x squared. You can have other things in that type of function. For example, you could also have y equals x squared plus 2. You could have f of x equals x squared plus x minus 1. So as long as the highest exponent is a 2, then it is a quadratic function. Now let's look at the table of a quadratic function. So remember how we called x the input? And y was called the output? So if I put x into this function, well, let's say if I have x squared, the parent function, then I would simply put x, which is negative 2, into the function. So if I take negative 2 and put it in the place of x, so I simply took negative 2 and put it in the place of x and raised it to the second power. Now, when you are squaring something, always put the base in parentheses. What this really means is negative 2 times negative 2. And negative 2 times negative 2 is a positive 4. If we repeat this process for each input or for each x value, let's see what our table would look like. Negative 1 times negative 1 is positive 1. 0 times 0 is 0. 1 times 1 is positive 1. And 2 times 2 is positive 4. So notice that you see this kind of mirrored pattern going on here. That's going to affect what the graph looks like. So let's move over to the graph of a quadratic function. I'm going to remind you again that x is your input and x is what you get out. So when we put in negative 2, when x was negative 2, we got positive 4 as the output. So I'm going to label 1, 2, 3, 4. So when we put in negative 2, we got out a positive 4. And I'm going to mark a point there. Next, when we put in negative 1 as the x value, we got out a positive 1. So I'm going to mark that point. When we put in a 0, we got out a 0. When we put in a positive 1, we got out a positive 1. And when we put in positive 2, we got out a positive 4. Okay, so simply all I've done here is just mark the points that we found in this table. So you could also go back if you wanted and create points. That would help you with graphing. So as a point, x, y, this would be the point -2, 4. -1, 1. 0, 0. 2, 1. Excuse me. 1, 1. And 2, 4. So I simply plotted those points in the graph. Now we can connect the dots. And it makes this kind of a U shape. The shape of this graph is called a parabola. Now let's look at some examples and get into the key features of quadratic functions. So when I say the words key features, think of that as if you were thinking about a person and you wanted to know what makes that person who they are. The key features of a quadratic are just the things that make that quadratic what it is in specifics. So remember the parent function is y equals x squared, or f of x equals x squared. And those points that we plotted, some of them are key features. They are really important points that make that parabola what it is. So we'll start with just a reminder that the graph of a quadratic function is called a parabola. Now the next key feature, the vertex. It's either a maximum, which is the highest point, or it's a minimum, which is the lowest point. So I want you to note in the parent function that's graphed here, the vertex is a minimum. It is a valley. So if it is a max, it would be when your parabola is upside down. If your parabola is right side up, the vertex will be a minimum. It will be a valley. Next, in relation to the vertex, you have the axis of symmetry. The axis of symmetry is a vertical line that goes right through the vertex. So the vertex is the point where the parabola is kind of cut in half and it mirrors each other on the opposite sides. So to describe the axis of symmetry, you can say it's the imaginary line that cuts the parabola in half. It's the imaginary line that goes through the vertex. And to write this line, it is always x equals whatever the x value is of the vertex. So this axis of symmetry goes through the x value of this vertex. So if our vertex is at the point 0, 0, then the axis of symmetry is x equals 0. Next, you have the zeros, roots, solutions, and x-intercepts. Those are 4 different words that all mean the same thing when you're talking about key features of a quadratic. So the zeros, the roots, solutions, and x-intercepts, they are all just the points where the parabola crosses the x-axis. Right, so for this parent function, notice that the parabola actually touches the x-axis at the vertex. So since the parabola touches the since the vertex is at the point 0, 0, then you're going to look at the x value of those points. We are going to do more examples. This is just the overview